We now talk about conductors in electrostatic equilibrium. So say you have a conductor. So it could be a steel plate or a metal plate or aluminum plate, and it is placed in an electric field. So notice the direction of the electric field. It is going from left to right. So electric field always comes out of the positive charge and goes towards negative charge. So the conductor will have charge arranged in it. So the conductor would have, on the right side it will have positive charge, on the left side it will have negative charge. That is, the electrons have flowed from right side to left side. The point we want to make is that electric field is zero inside the conductor, and the conductor itself is in electrostatic equilibrium. So electrostatic equilibrium means that there is no net motion of charge inside the conductor. So there is no net motion of charge inside the conductor. Now why is electric field zero? That is what we want to answer. Now the electrons arrange themselves as above. So electrons have flowed from the right side to the left side because of the electric field. So electric field will come into the electrons and it will go out from the positive side. So once the electrons arrange themselves as above and they are not moving anymore because the conductor is in electrostatic equilibrium, you get a new field which is opposite to the given field. And this new field will cancel the outside field. So this is the field in green is inside the conductor. This inside field cancels the field which is outside. So net inside the conductor you have zero electric field. Now the second point I want to make is that on an isolated conductor, the charge resides on the surface. So say you have a conductor, let us draw a conductor. Then the charge is only on the surface. So the charge will reside on this green layer, only on the surface, not inside. Now there is no electric field inside the conductor. So this we get from the first point above. Thus, there can be no flux. So because flux is generated by the electric field. So by Gauss's law, the flux is charge over E0. Now if flux is zero, the charge will be zero. So inside the body, since there is no electric field, there will be no flux. Since there is no flux, there will be no charge inside the conductor. So if you have a charged conductor, that means all the charge has to be on the surface of the conductor. Because inside the conductor, electric field is zero, flux is zero, and therefore charge has to be zero. Now another way to see point number 2 is that if there is electrostatic equilibrium, then there is no net motion of charge. So that is the definition of electrostatic equilibrium. There is no net motion of charge inside the conductor. Now if there is no net motion of charge, the potential difference between 2 points is always zero. So that is, potential energy inside the conductor is zero because nothing is moving. So potential energy is same as motion of, say, water. So since nothing is moving inside the conductor, no electrons are moving, so potential is same everywhere. So potential difference is zero. So in particular, if you go from point A to B, the potential difference would be zero. Now this 0 is equal to minus integral of E vector dot dx vector. Since displacement from A to B is non-zero, the only way this is possible is if the electric field is zero. Again, electric field is zero means flux is zero, which would imply charge is zero inside the conductor.